Hello everyone, my name is Abraham, and in today's video we'll be discussing about relation between current and drift velocity. So let's get started. So before I start this particular topic, let's do a quick recap of what drift velocity was. So in the previous video we talked about drift velocity. Now drift velocity was defined as the average speed or average velocity of free electrons when they are inside the conductor under the influence of an electric field, right? So let's say for example this was your conductor, and let's say the switch is on, then the average speed of these free electrons will be known as your drift velocity, right? Now in the previous video we calculated the magnitude of drift velocity. Now the magnitude of drift velocity was coming out to be Vd that was equal to E times of capital E upon M times of tau, right? Where E was the charge of electron, E was the electric field, yes or no? E was the electric field, and M was the mass of electron, and tau was mean relaxation time, right? I hope that is understandable to you. Yes, okay, great. So that was the magnitude of your drift velocity. Now let's look at the topic. The topic is the relation between current and drift velocity. Now drift velocity is something which we already know. Now I need to find out the value of current in order to find out the relation between current and drift velocity, right? So obviously you guys can see I have this conductor which is connected with a battery source. Let's say the switch is on, right? The switch is on. The moment the switch is on, what is going to happen? These electrons will be traveling with drift velocity in that direction, and the electrons will travel like that, yes or no? And the electrons will travel like that, yes, okay. So because of the traveling of electron, there will be a current, right? Remember, current will be in the direction opposed to that of your electron flow, right? So the current will be in that direction, right? So I'm supposed to find out the value of this current in order to relate it with drift velocity. I hope you guys can understand the concept, right? Yes, okay. Now we know that current is given as charge per unit time. Now this is something which we already know, that current is given as charge per unit time. That is, charge is actually equals to the flow of electron, and time is how much time it take for the charges to cross, right? Okay, great. So I know the value of current. So important thing, I have to find out the value of charge, right? What is the charge that is flowing inside my conductor, right? So I'll be taking some steps in order to find out the value of charge, so you need to be very careful here, right? Okay, now first thing, I will define a term N. Now what is N? N is number of free electrons per unit volume inside the conductor, right? So N is actually, let's say this is the conductor, so N is the number of free electrons which is present inside this conductor per unit volume. In a unit volume, how many electrons are present, right? So in a unit volume, how many free electrons are present inside this conductor, that will be given by the variable N. Yes, okay, let's move forward. Next is L into A. Now let me just very quickly tell you, L is the length of this conductor. This is a cylindrical conductor, and let's say area of cross section of this cylindrical conductor is some A, right? So if I multiply the length with the area, what will I get? I'm multiplying the length with the area. Area already has two dimensions, length is the third dimension, so you multiply all the three dimensions here, you will get volume. Yes or no? You will get the volume. Yes, great. So L multiplied by area will give me the volume of the conductor. So now I know the volume of this entire conductor, right? Great. Next step, I will multiply number of free electrons per unit volume multiplied by the volume of the conductor. Now what I will get? I have multiplied the volume of the entire conductor with number of free electrons per unit volume. So when I multiply it, yes, what will I get? Yes, correct. I will get number of free electrons inside the conductor. Inside the conductor, how many number of free electrons will be there? I will be able to get with the help of this multiplication. That is number of electrons, free electrons per unit volume multiplied by the volume of the entire conductor. Now with this value, I know number of free electrons that are present inside my conductor, right? Great. Now my ultimate goal was to find out the charge inside the conductor, right? So I know the number of electrons, which is number of free electrons which is present inside the conductor. So how I can know the charge? Yes, I have to multiply this quantity with the charge of one electron, that is E. So if I multiply the number of free electrons inside the conductor with the charge of one electron, I will get the total charge on the conductor. Is that a yes or no? So I'll get charge on all of the electrons within the conductor. That is the total charge on your conductor. Is that a yes or no? Right? Okay, so one problem is solved. I know the value of charge now. I know the value of charge now. The problem here is I have to talk about time now, right? So how I can talk about time? So if I know the value of time, then I can simply find out the current that is flowing inside my conductor, right? So very similarly, you have to. So I'll do a simple assumption here. Now what is the assumption here? So this is my conductor, right? So let's say this is my conductor, and I'll simply assume, it's a wild guess, it's a wild assumption, right? So I assume that all of my electrons, all of my free electrons, you know, they are starting from a starting point, right? So they are at the starting point and they will move to the end point, right? So this is a simple assumption that all of my free electrons are at one end of my conductor, and from that one end of the conductor they are being drifting towards the another end, right? So the assumption is that when they were at the first end, the time was considered to be 0, and the assumption is that these electrons took some t time to travel this particular distance. Let's say the distance is L, right? So why I'm doing this assumption? So that I can make my calculation easy, right? So that is the only purpose of this, you know, exercise, right? So my electrons are at one end of my conductor and they are moving towards the another end, and for doing that it is taking some t time. It has traveled some L distance. Is that a yes or no? I hope you guys can understand that. So that is something which is written here. When the key is pressed at t is equal to 0. So at t is equal to 0, the key is pressed and the electric field is set up, and the electron drift in the direction opposite to that of your electric field, right? So electric field will be in that direction. Electrons will going in the opposite direction, right? Great. So let's say it take t time for the electrons to drift out of the left cross section. So it is taking some t time so that this electron can drift out of your left cross section. Is that a yes or no? Okay, great. So now I know the value of time also, right? So all I have to do is I'll just simply have to equate the things, right? The electric current in the circuit will be, so the electric current in the circuit will be simply given as I is equals to Q, charge per unit time. Now what is the value of charge? I hope you guys can remember the value of charge was NLA multiplied by E. That was the value of charge, right? So I'll simply write it here, NLA multiplied by E, that is the value of charge. And let's say it took some t time to travel that charge from, you know, 0, from your from your one end of your conductor to the other end of your conductor. Is that a yes or no? So it is divided by t. Now here is the important thing you have to understand. It has traveled L length in t time. It has traveled, the electrons have traveled L length in t time. Now can you guys relate this thing? Can you guys relate this thing as the displacement per unit time, right? So this L upon T is the displacement done by your free electrons in some t time, right? So what is this displacement upon time? What is displacement upon time? Yes, it is actually the velocity. Now I know the velocity of this electron is the drift velocity, right? So if these electrons are traveling here, so basically they are drifting with Vd, right? So basically this L upon T tells me or gives me the drift velocity of all of the electrons. Is that a yes or no? Can you guys understand that? Yes, the displacement, that is the L length that is traveled by your electron in t time is actually the velocity, and that velocity is the drift velocity which we have studied in the previous video. Yes or no? I hope you guys can understand. So instead of L upon T, I can simply write Vd. So the value of current will be equals to Vd times E times N times A. Is that a yes or no? So this is the relation between your current and the drift velocity. So in order to memorize this, we simply say I is equals to V now. I is equals to V now. So you guys can see I is actually equals to V, that is the drift velocity, E N A. So I is actually equals to V now. So this is a simple trick so that we can remember the formula of current and your drift velocity. Okay, let's move forward. Let's move a little bit further than that. So I know I can simply write the value of drift velocity here. When I equate the value of drift velocity, you will get E times of capital E upon M upon tau and E now, right? Is that yes or no? So when you complete it, you will get E square tau E N A upon M. Is that a yes or no? Right? Okay, so let me say this is my equation number 1. So I know the value of current. This is the value of current that is coming out to be, right? Okay, next I have this conductor, right? I have this conductor. Let's go to the first figure. So I have this conductor. So let's say this conductor has a potential difference across it, right? The potential difference across it can be simply written as E times of L. Yes or no? Now this is something which we have studied in our second chapter, and I'm sure you guys will be knowing this. So I can write the potential to be E times of L. E is the electric field, L is the length of the conductor. Yes or no? So that will be my second equation. So let me write it yes. So first equation is this, second equation is this, V is equals to E times of L. Now what I'm going to do here is I'm going to divide my second equation with the first equation. So just wait a minute, I will tell you, I'll explain why I'm doing this. So I'm dividing equation number 2 with equation number 1, right? So when I divided equation number 2 with equation number 1, you get V upon I is equals to EL. EL was your, potential, divided by E square tau E N A, and the M will go up. Is that a yes or no? So very simply, what I can see, my electric field will be cancelled out, and you will be left with V upon I is actually equal to ML upon N E square tau A. Now let's see what is this M. M is mass of electron. Yes or no? What is the L? L is length of the conductor. Okay, length of the conductor. What is N? N is number of electron per unit volume. Okay, what is E? E is the charge on electron. Very good. What is tau? Tau is mean relaxation time. Mean relaxation time. Yes. Okay, great. What is A? A is the area of cross section. Area of cross section of the conductor. Yes or no? Alright, so all these value, let's talk about mass of electron. Mass of electron is a constant quantity, right? It's not going to change anywhere. Length of the conductor, let's say I have fixed the length of a conductor, then the length will also be, will be a constant quantity. Okay, number of electrons per unit volume is anyway. So for example, if you have choose a particular, if you have chosen a particular length or a particular area of cross section conductor, so inside that the number of electrons per unit volume will anyway going to remain same. Yes. Okay. E, charge on electron is anyway a constant quantity. Tau, mean relaxation time for a particular conductor at a particular temperature will be a constant quantity, right? So I'm not changing the temperature remains same, the length and the area of your conductor remains same, then it is going to be a constant quantity. area of cross section of current is anyway constant. So basically, when the physical conditions of your conductor, physical condition means the length, the area, the temperature, the pressure, so when all these conditions, physical conditions of your conductor, when all these conditions remain same, then the ratio of V upon I is actually a constant. Is actually a constant. Can you guys remember what it is? It is actually what the Ohm's law is. This is the famous Ohm's law, right? So that is the ratio of V upon I is a constant quantity, that is your resistance, right? This entire term is equated to your resistance, right? I hope you guys can understand that. Yes, so we will actually go further from here. So you guys have to remember V upon I is actually written as ml ne square tau a, right? So you guys can see this is the famous Ohm's law, that is V upon I is actually equals to ml upon n. Okay, it will be n e square tau a, right? So you guys simply, if I move further, you guys can understand V upon I is actually equals to R, is actually equals to ml n e square tau times of a, right? So you guys can see R is actually written as ml n e square tau by a. Now you also know the resistance is also written as rho L upon a, right? So just compare these two equations, you will see the value of rho will be given as m upon n e square upon tau, right? So from here we actually find out these are the origins of your resistance, these are the origins for your resistivity. So rho is known as your resistivity, right? And R was your resistance, right? Resistance. So we will talk about this in the coming video. I'll just show you guys so that you guys can understand from where the resistance and resistivity comes, right? So I hope you understood the video. I hope you understood the relation between your current and drift velocity. The value of current is actually equals to V now, right? So in order to understand, in order to remember that. So I hope you understood the video. If you have any doubt, you can comment it down in the comment section. So that's all for today. Thank you and have a nice day.